So hello, everyone, and welcome to this Iliad webinar series. Today, we are going to talk about commercialization of digital twins. My name is Bente Lilja Bye. I am your host as usual. And with us today, we have like a fantastic panel of experts that will help us and inform us and inspire a discussion around this commercialization of digital twins. I will start actually by showing you a short overview of our excellent speakers that you will get to know, of course, closer later. But before I start that, I will just remind you of some housekeeping. Keep yourself muted while the speakers are presenting. Towards the end, after the presentations, you will be given the possibility to ask questions and discuss and comment. While you are listening to the speakers, please do write in the chat so that we get that as that the thoughts falls into your head. Please transform it over to the chat, and then we will take it up in the discussion session. With that, yes, I can start. This is recorded and will be shared with you also afterwards and made available on the Iliad website. So now I'm going to share with you the absolutely top-notch panel of speakers that we have. And here you see we have Sofia Parsadanyan from the American University of Armenia. She is our expert on commercialization and blue economy. Then we have Valentin Golovtchenko from the World Economic Forum, Pierre Erwes from the BlueForwardFund, Phoebe Koundouri from the University of Athens, and many other institutions, by the way. Among others, the University of Cambridge, where we also have Ali Mashayek. So those are the panels that you will learn more from, the speakers that you will learn more from today. The topics are as follows: the Iliad Tech transfer capacity building support that Sofia will talk about. Then we are going to learn about navigating the challenges of commercialization or commercializing Earth observation data by Valentin. And then the role of blue economy in co-designing digital twins by Ali. He will share his thoughts on that. Followed then by socio-economic perspectives on commercializations of digital twins. Phoebe will either be here with us via video or in person. We will see how that goes. And then last but not least, commercialization of digital twins, venture capital funds perspective by Pierre. And then at the end, all of us to discuss these issues. So before we dive into the details, just a quick fix on digital twins of Iliad. Digital twins of the ocean is, very shortly said, a replica of the physical reality. We say that these twins are providing a virtual environment representing the ocean, and they're capable of running complex and predictive management scenarios. Its innovative systems integrated across different disciplines, sensors, models, and digital infrastructure. It's a complex world. And to manage this complex world, the Iliad approach and concept is that we recognize the fact that the ocean is vast and complex, consisting of all these different components, including the human activities. There are many resources already available in Europe and beyond for that goes into the creation of digital twins. And we are looking at federating these existing resources and making them interoperable. And in addition to that, we also have some sensors included in the Iliad project. So we are expanding on that. In addition, we are also working quite a bit on including citizen science, both contributions in forms of data and information, but also as an engagement methodology. So existing, in short, is the Iliad in the seashell is enabling an ecosystem of interoperable digital twins. So we are talking about different twins through connecting the existing ocean data infrastructures, and we are enhancing it with more additional informations and citizen science. We make these results and resources available on a marketplace so that you can either use it as is or put together the components to create your bespoke digital twin. And of course, in itself, there will be these twins are providing solutions that to help solve problems. So I said multiple twins of the ocean, and we have divided it into different thematic areas. You see here 12 different areas. So existing wind farm capacity, ocean energy, coastal sediment, plastic pollution monitoring, oil spill simulation, insurance for marine and aquaculture, and jellyfish swarm forecast, harbor safety, metocean and hind now and forecast, fisheries productivity and sustainable aquaculture, ballast water monitoring, and aquaculture and harmful algae bloom, and water quality and ship traffic. So you see, there's a lot of thematic areas, and they are also on specific locations. Now, to mention an example on oil spill, we have in Greece, there's one of the pilots, twins, is actually combining then different models, so ocean currents models, information about the water quality, ocean currents, tide gauges are involved in it, and also citizen science. And when you have an incident, an environmental incident, like an oil spill, you can then monitor, monitor what's happening when you have a model that foresees where this oil will move in the sea and where it will hit the ocean, the shore, and then you can plan accordingly. And this is as the users, so the clients and users of such a digital twin will then be both environmental people responsible for safeguarding environmental issues, for ecosystems, and also for the oil companies who will be responsible. And it implies a cost for them if they are not managing such an accident in the best possible way. So just to mention one example of how a twin can be useful for both public and private activities. Another example of a twin that we are developing is combined for the insurance industry and the aquaculture industry. So since I'm from Norway, I know, of course, that aquaculture is a big business. Actually, we are the biggest producers in the world in real numbers. So what happens to the aquaculture farms is important to the aquaculture managers, of course, and owners, as well as the insurance industries who are then insuring these activities. So we had an example a few years back where we had a harmful algae bloom, and that cost billions of dollars. That was a loss. It was a huge event that was both had a great impact both on the industry itself and the insurance industry. So therefore, a digital twin for the insurance industry / the aquaculture farmers will be of great use. And we are developing that in Iliad, where we are combining ocean models, both Copernicus, which gives us a lower resolution information about the ocean, say, and local models that we develop in Norway with higher resolution, and combined with other types of information, also economic information about the farms, for instance. So I just want to paint to you that this has really economic impact, and it also have a social impact, etc. And having digital twins will then potentially be of great use in these cases. The project Iliad is a rather big one in European framework terms. It's a innovation action, and we are 56 partners. The total budget, with including the contributions from the partners, is close to 19 million euros. And we are in the last, well, the project has been extended, so we will be finished by next summer, summer 2025. And with that, I will end my presentation. I'll admit this. And let Sofia go deeper into how we are supporting these twins in terms of tech transfer and potential commercialization. So Sofia, the floor is yours.
Hello, everyone. Thank you, Bente. Well, my role is here today is to give you a brief overview on what exact efforts towards technology transfer and commercialization we are making within the Iliad project, because we have like a big technical part of the project, developing all these solutions and making all this data available. And we have a big capacity building part of the project, part of which is actually efforts on technology transfer. I will show my screen because I prepared a couple of slides. I hope they are picturesque enough. I believe you can see my screen. So technology transfer and commercialization context within the Iliad project consists of a few elements, actually. As Bente mentioned, we have a marketplace where all the data and solutions are available for the end users and solution developers. But the main probably one of the biggest technology transfer efforts is to set up a facility where researchers and project developers would be able to figure out all the resources that are available for them.
Sofia, sorry to interrupt you, but you are not showing your slides in presentation mode.
Oh, sorry. Sorry, I can fix it.
I interrupt because of readability.
Sorry. Is it okay now?
Yes.
Thanks. Okay. The main effort on technology transfer inside the Iliad, I believe the main effort on technology transfer is to set up a technology transfer facility. So basically, we're developing a big database of the incubation programs, acceleration programs, different type of grants on EU level and on national level that are available for startups, for scientists, for tech transfer officers, and it will look like basically like this. So this system we are developing will be able to detect the technology readiness of each project. And based on the technology readiness level, the user of the system, the researcher, the scientist, or product developer will get the information of what type of funding sources is available for him and for his project, what type of associations of end users he can reach out to actually engage and co-design whatever he is developing. The important part of commercialization is actually intellectual property protection. And we have selected services on EU level within the Horizon project and a few other projects, which provide scientists around the Europe and associated countries with a free consultancy services on how to protect their intellectual property. Basically, we noticed that there is no one-stop shop for all these type of resources. So basically, scientists and every user, they can use Google and to find whatever they need. But we noticed that we don't have one-stop shop where you can find all these resources in one place and actually save time. So the main value of this technology transfer facility is to save time for researchers and scientists, to give them a perspective what type of resources they can attract to commercialize their project. This will be valuable if we assume for them or for the technology transfer officers within their research institutions. And again, we are developing it inside Iliad, first of all, for the Iliad pilots. So we will test it with them, and then we will test it externally. Basically, that's it for these technology transfer efforts. I hope I didn't take a lot of time.
Thank you very much, Sofia. And by the way, I forgot to actually proper introduce you. Apologies for that. So Sofia is a project manager at the American University of Armenia. And she's leading EPIC, Entrepreneurship and Product Innovation Center. And she has a long experience from technology transfer and commercialization in the research done by scientists in Armenia.
I will maybe add that we are responsible for developing this technology transfer facility. That's why I'm emphasizing that this is maybe the main effort on technology transfer. But within the Iliad, our colleagues are putting efforts in developing some to investigate innovation business models, how you can commercialize with digital tools. That this is not software, not solution. This requires some specific maybe business plan or business efforts. But me as leading the technology transfer facility setting up, I believe this is the main. Thank you.
Thank you, Sofia. Now, swiftly over to you, Valentin. So Valentin, he is leading the World Economic Forum's work on climate technology within the Center for the Fourth Industrial Revolution. And he drives initiatives on technology for climate adaptation and Earth observation data, and exploring impactful technology solutions for a sustainable future. And before joining the forum, Valentin worked in the aerospace industry as a management consultant and industrial engineer, specializing in technology innovation in supply chains and manufacturing operations. We are looking forward to tap into your expertise, Valentin. The floor is yours.
Thank you, Bente. And I will just share some slides, if that's okay, because it seems like that's what everyone is saying today. All right, so thanks for inviting me, first of all. So contrary to many of you, I am not an expert on oceans, but I do look at Earth observation data more broadly, and I'll get into what that means in a few minutes. And I think there are some interesting lessons learned from our work there, especially when it comes to driving adoption of the commercial use of these technologies, maybe for Earth observation data in general or digital twins more particularly. But before I get there, I will just share a few information on what is the World Economic Forum, what we do, what we don't do, and then get into the details of our work on Earth observation. So for those of you who don't know us, we are mostly known for our annual meeting in Davos in January. That's usually where we make headlines, but we actually are an organization that works year-long with a community of stakeholders that work with us to solve problems for a wide range of problems. And we have developed several initiatives to address these. Just to give you an idea of the type of stakeholders we work with on a day-to-day basis, it ranges all the way from businesses to governments, academia, innovators, philanthropic entities, and so on. And our approach is really that multi-stakeholder cooperation. So we go beyond just public-private cooperation, but we really try to get as many voices in the room as we can to really share that, differences in views. So how have we evolved? There's a good reason why we are mostly known for our annual meeting in Davos, because that's how we started in 1971 by organizing that event. And we've done so every year since, except in 2021 for obvious reasons. But we have now resumed the annual meeting in person there. But we have mostly evolved into something bigger than just events. So we started by building communities. So these are the group of multi-stakeholder groups that I mentioned earlier. and then all the way to developing knowledge through our different digital platforms, then to projects, and now to actually being that platform to drive change on a global scale. So how do we achieve change in general? Well, this is really a three-step process for us. The first one is building awareness and shaping the agenda. So for that, we bring together these different people from different walks of life, and we really highlight the shared knowledge that they have, and foster that knowledge exchange between different types of people so that we can get business talking to government, for example, with startups in the room, academia, and really fostering that knowledge exchange. Then we try to guide strategy and inform decisions based on these conversations. So that's when we come to publication. So we publish regularly throughout the year white papers, policy frameworks, reports, really to drive change both at the governmental level and in industry. And then more and more, we are trying to move towards driving impact. So that is curating these alliances between different stakeholders that we can provide the platform for them to build upon. And really using that platform to drive change in the world. So that's enough about the forum. Now, what do we do about Earth observation? So I like to start with this because I think at the core of what we do is who do we work with? So we work with a community of around 50 members now. Around half of that is business and half of that is non-business. And on the business side, we work with an interesting group of, and you have the names there, I would say Earth observation data provider at large, but also end users in end user industries, in financial services, in agriculture, in energy, and so on. And we like to involve in that group also smaller innovators. They are big names always, but we like to have these smaller startups that are sometimes disrupting the industry, even though it's very new. And that can come and have that conversation with us. And then on the civil society, academia, and government side of things, of course, we engage with the national space agencies, but also with several UN agencies like UNICEF or UNEP, and academia and others. So what do we work on precisely? And I think it's important to have these definitions cleared out because sometimes when people speak about Earth observation, they speak about different things. Our definition, and of course, happy to have that conversation, is the following. So we look at Earth observation throughout what we call the EO value chain, all the way from acquiring data to processing it, transforming it, driving insights from it, and then to using it in end user industries. And we do that both for remote data, remote sensing data, like from satellites or drones, for example, but also with in situ data, like we can use IoT sensors. That's also part of our definition of Earth observation. Earth observation measurements. So we look at all applications of Earth observation. Most people usually think about images in the visible spectrum, but we look at all other types of variables that can be measured about the Earth, all the way from water coverage to vegetation species to temperature and heat sources. And we look at the use cases that you see on the right-hand side. The reason why this list is really high level is because we want this work to speak to many different industries. And so we have defined this list of 9 application areas of Earth observation that go beyond industry-specific use cases and that can relate to all stakeholders in the room. And at the bottom, I'm not going to go through it, but just giving you an example of the types of use cases that we cover as part of our work. All right, so we started this work around a year ago during Climate Week 2023 in New York, and we got all these people that I introduced before in the room, and we started discussing what's the state of Earth observation today, and can we do something to accelerate and drive adoption of it? And this is what we came up with. So this assessment of the fact that the market is really changing quickly. Even though Earth observation has been around for 50 years, and we can think about programs like Landsat that's been around for a really long time, there is, and that's a fact, an explosion of available data today. And it's particularly interesting because we can see the rise of new commercial entrants as well. In a market that was dominated by government agents, we can see a lot more commercial companies now building and operating Earth observation satellites in particular. So what's happening now? Well, first of all, the environmental imperative. I think that's a big change in recent years, is that there is a growing understanding, including in business, that there is no time. We cannot wait anymore. We need to act now and we need to act now on the climate crisis. We need to understand better what is actually happening. And for that to happen, we need to have precise data. And that's where EO has a role to play. And also another key driver that we're witnessing nowadays is the focus on solutions and not pixels. Historically, in the Earth observation market, people used to buy pixels. So you would buy pictures over a certain period of time with a certain resolution, and that would make a price. We see more and more now, especially end users, asking for more packaged solutions. They don't want to build the in-house capabilities to actually process and extract insights from Earth observation data, but rather they want these insights to be the solutions that they buy in the first place. And what we're trying to do, we are a bit optimistic here with the coming next, that's what we hope will happen, is really amplifying that movement and coming up with these new sensors that are coming online. That's happening nowadays. We can think especially about hyperspectral capabilities or SAR, that are technologies that are, I mean, not exactly new, but are starting to become really mainstream and that we can derive new insights from. But more importantly, it's all about this adoption. And that's what we decided to focus on now with our work, is how do we drive that adoption further? So what we did is we ran an economics study, because what we found is many organizations say that they care about the planet, but when you can present them with businesses that combines at the same time economic value for them and climate value for the planet, that's a much better case to make. So we started measuring how much value can actually EU derive in industries. And the first finding we had at the macro level is that downstream use is really the value multiplier there, which is that everyone focuses on the size of the Earth observation market itself. But what everyone should be looking at is what it can unlock in other industries when using that data. And we run our simulations, and I'm happy to share our report that gets into the details of that. But what we found really is that the great thing about Earth observation is it has two values in one. So it can at the same time generate huge economic potential for the world industry. And you have that figure on the left-hand side, up to $700 billion value added to the global industry in 2030, if it was used at scale. But at the same time, 80% of that value is actually tied to use cases that can also have climate positive benefits. And you have a list in the middle here. I'm not going to get into the details, but if you add all of that together, it can help reduce up to 2 gigatons of CO2 per year, which for reference is equivalent to approximately 1/3 of the combined emissions of the cars in circulation in the world today. It's definitely sizable figure there. What we found as well when we went, because we wanted really to drive that adoption with the private sector, is that a lot of these use cases are actually private sector applications. So you can see in here, agriculture can disproportionately benefit from EO, but also other industries like energy, utilities, trade and transport, financial services, and so on. And then by region, and that's the last slide with figures. Apologies for that, but I think it's an interesting one. Today, this market is dominated by North America and Europe, because historically, these have been the players that have been engaged in collecting that data and using it. But if we look towards 2030, where we see the most growth potential is actually in other regions of the world, Asia Pacific in particular, but also Central and South America, Africa, and the Middle East. Just a few more words before I close today. And these are the lessons learned. Like, what have we learned through this project, working with these partners on how can we scale EO's commercial use? And hopefully some of that can apply to digital twins of the ocean. So the first one was really about the awareness. In many cases, especially executives in large organizations either do not know that Earth observation can have positive benefits for their organizations. But even when they do know, they see it sometimes as something overly complex. And I think the same thing can be said about digital twins. While democratizing actually the use of these technologies is definitely something that can help drive adoption. If we can help these executives understand that it is a complicated technology, but you don't actually need to have a whole team of dedicated data scientists to start using it. You can actually buy some prepackaged solutions. There's already a lot of data sets that are presented in accessible formats. If you can really help with that awareness, that can go a long way in driving adoption. The second one is about open standards data and solutions. Even though the space is more and more moving towards commercial data, we believe that there is a pre-competitive layer of open data that can go a long way in driving innovative solutions downstream. For us, the innovation should actually be focused more on the solutions and on how we use the data than the data itself. And the more open the data, the more innovators can come and derive actionable insights from it. Then, of course, investment in technologies, that goes for all types of tech, so I'm not going to delve into this one. But the one that is important is focus on equity. if we look at the climate crisis in particular, it is disproportionately affecting the global south today. And most capabilities to actually derive sense from EO data are either developed and or used in the West. So driving that equity and access to not only EO insights, but also capabilities to derive not only to data, sorry, but also to capabilities to derive insights from that data is definitely critical in driving that adoption and at the impact globally. And then the last one that I mentioned already is moving from pixels to solutions. If we can more and more stop showing pretty maps to people, but telling them what these maps mean for them rather, and how they should act based on these maps, that will go a long way in driving insights there. And that's it.
Thank you very much, Valentin. This was very interesting. I have a few questions, but I will control myself and wait until the end, as everybody else, because you can stay on, right, Valentin, to the discussion?
I can stay on until 4.
Oh.
So hopefully,
Okay.
we have some time.
We have some time. Then we hastily go on. And I think the next up is Phoebe. How are we doing with the video? Katya, behind us here, behind the scenes? Do we because Phoebe offered, she really wanted to contribute, and she offered a video, and perhaps also through the help of Ali, if the video is not working, we can have Phoebe from a car talking to us. Okay, we have a video here. Thank you. Then I will share the video. Hold on. Let's see. Yes. So let me know if you hear. You don't hear,
No.
Sofia?
No.
Okay. Let me see if I can playback speed. Normally this should work. No. Maybe there's something here. Let me see. Just very quickly. Let me try now.
And business and at the Technical University.
Yeah.
I also lead the United Nations Sustainable Development Solutions Network Global Climate Hub, and I'm the president of the World Council of Environmental and Natural Resource Economies Associations. This includes the European Association, the US Association, the Latin American Association, the African Association, the Asian, and the Australian Association. I'm gonna take these 5 minutes to showcase the need for digital twins, but not just earth sciences digital twins. I will advocate for the need of integrated digital twins between earth sciences and the socioeconomy. And in doing so, I will showcase the work that we do, and I hope you can see my slide at the Global Climate Hub of the Sustainable Development Solutions Network, which is a global network with 2,000 university members working on the implementation and development of solutions relevant to the implementation of the Sustainable Development Goals of Agenda 2030. So this Global Climate Hub focuses on developing pathways to meet policy targets. The SDGs are our global agenda. The SDGs have been transposed in various regions and countries of the world in elaborate policy framework. In Europe, for example, we have the European Green Deal, which is a big framework, policy framework of regulations and laws and directives, focusing on the implementation of climate neutrality, ecosystems, resilience, clean tech leadership of European companies, and socio-economic cohesion, not to leave anybody behind. So we have our targets and we have the policy framework to meet our targets. At the same time, we can measure the level of achieving these targets. At the United Nations Sustainable Development Solutions Network, every year we produce a report that showcases what is the performance of different countries and regions of the world and sub-regions of the world with regards to implementing the SDGs. So we have a measurement of where we are, and we also have our policy targets, which indicates where we want to go. In order to develop the pathways to cover the distance from where we are to where we want to go, we need to understand and model the interaction between the natural systems that a digital twin can give us, and the economic system and the social system. And in doing so, we need to work on the green layer of the Global Climate Hub, which I call interdisciplinary mathematical modeling for developing resilient mitigation and adaptation pathways. And here we downscale climate scenarios, we work on energy systems and how they can become climate neutral. We work on transport systems that are climate resilience and climate neutral. We work on land use and food use systems and marine use systems and how over time they can become climate neutral, health systems and innovation systems. And every time we try to identify the most cost-efficient technologies, the additionally needed policies, and also try to answer the question how we are going, the pathways, the optimal mixture of technologies and policies and transformations that are going to be implemented. So the results of the climate system, the energy and transport system, the land use and marine system, the health system, the innovation system, are integrated into integrated assessment models that derive the socioeconomic pathways. And this is the green layer. The blue layer is the layers that integrates in this interdisciplinary systems approach stakeholders participatory approaches, which starts day one of the systems thinking of the green layer above, and basically works with the stakeholders to validate every step of the systems integration. And not only that, but it also equips the stakeholders with the skills and knowledge in order to understand the problems and understand how they can engage in the co-design and also become shareholders in the solutions that are going to be implemented. These two simultaneous processes, the scientific and the stakeholder engagement process, can become another layer in the Earth Sciences digital twin. And this layer will be very efficient, and this is what we are already building as the climate data platforms and digital applications, third layer of the global climate hub. And it will allow not just modeling the Earth systems, not just modeling the interaction between the Earth systems and the energy systems, the transport systems, the land use systems, the marine use systems, the health systems, the innovation system. It will also allow socioeconomic and financial support, evidence-based, science-based support of the integrated pathways that will derive from the systems. So at the end of the day, you have a digital twin that provides really holistic and integrated policy advice. And this policy advice can refer to governments and regions of the world and international in the international space, but it can also be downscaled to company level. It can also be downscaled to corporations level, to financial institutions level, in order to understand how they can move from where they are to a climate resilience, climate neutral, but also biodiversity resilient and SDG resilient world. It is definitely deployable massively, and it has a very robust business case because it can really provide holistic, implementable policy advice that integrates nature, society, and economy at all different levels, at all different scales. The corporations can follow this work that it is being transposed into a digital twin, into a tool, in order to identify the most efficient and resilient way to transform in order to become compatible with the new era of the green and digital transition. The financial institutions can do the same. The local authorities can do the same. The regional authorities can do the same. The national authorities can do the same. The international authorities can do the same. So as long as you allow different scales in the structure, as long as you allow detail in the data and in the modeling, as long as you allow integration of all three layers, nature, society, and economy, and as long as you allow advice that is really transformative, but can also be implemented because you can identify the financial model for the implementation, then you have very useful tool ready to be massively deployed, a tool that does not exist yet, and it is really needed. Thank you very much for your patience. I will just say that this is work that is started under the Alliance of Excellence for Research and Innovation of IFORIA, which is a team of 200 researchers that I lead, and it works in a very interdisciplinary and intradisciplinary approach. Thank you very much for your patience.
So there you have it. We made it, and a big thank you to Phoebe. You can pass that on also, Ali, since you are working with her. I will tell her herself also. We are moving. I'm looking at the time. Let me see. Yes, do write your questions in the chat. We have Ali now. We switched the order a little bit because Ali found that this would be a better fit for his intervention here. And I think we jump directly to it. Just a short little swipe to the polls. You might have noticed that we were offering some polls here. We were asking what is the main challenge in commercialization, and you see here the results is legislation gaps, IP issues, or is difficult to engage with the end users. Difficult to the end users won this competition. So I just wanted to share that very quickly. We will share also in the documents after the following the webinars here. Okay, Ali, now it is your turn. And Ali and I, we met last week or the week before, I don't remember, in Japan. We were both attending the Science and Technology in Society Forum, where I also met Phoebe, by the way. And now, yeah, so you have some slides, Ali, do you?
Yes, can you see my screen?
Yes, I can. So Ali is a professor at the University of Cambridge, and I simply give you the floor, Ali.
Yeah, no, thanks for having me. I'll try to be efficient with time. We do, just for context, we do work with Phoebe's team. We're forming an institute at the University of Cambridge, which is precisely focused on linking the natural sciences part of digital twins to socioeconomic modelings in a way that you can actually directly make connections to stakeholders and investments. And so that's, if anybody is interested in what we are doing together and how we're trying to connect them, very happy to talk to you, reach out to me or Phoebe or both. So I'm an earth scientist. I'm a climate scientist. I've done quite a bit of modeling. So I'm just going to make a few trivial yet nerdy points. One is that, and most of what I'm going to say is biased by my focus on more global or semi-global ocean-based twins. So the first thing, that whatever component of the system that you get is a part of the bigger picture. And it's fairly common when we do regional modeling of any sort, or if we do modeling or create a twin that covers a certain period of time, that we focus specifically on that in terms of how we initialize it, what are the boundary conditions, and what we impose at the boundaries of the domain. And then we actually get into details of developing the models, assimilating data, and go to put a lot of effort in quantifying error and so forth. But from my experience with regional modeling, let's say for coastal flooding and other applications, it's fairly common to not propagate the uncertainties and errors that come from outside of the domain or much further in the past in terms of the history of the processes. So point being that it's very important I think we always need to keep the pressure on the need for incorporating what is outside of the domain that we're considering spatially and temporally. So it's a part, whatever we're looking at, it's a part of a bigger picture. Now that brings me to the point about the history, that the history matters. And if you think about the history of the Earth, that, the 4.5 billion years, that black line here on the right, at the very end, that is the entire sort of timeline over which we as a species evolved. So the Earth has been around for much longer. Now, that matters in the sense that the past informs the future. We all know of the butterfly effect. We all, not all hopefully, but some of us at least have seen multiple representations of multiverse in DC or Marvel movies now. But the point is that, about 50 to 30 million years ago, there were forests and monsoon season over Antarctica with very large mammals. So for the same, let's say, CO2 levels, you can have very different climates. And so it is very well known that climate, for the same conditions, you can have very different climates. And that is dictated by the history of how you actually get there. Now, so more recent research in the past decade has shown that even if you really care about the next few decades or 100 years, you really need to care about the past few 100 years to 1,000 years. Like, for example, my own research studies the deep ocean circulation and its tipping points. And if you think about the early warning systems, to get the right statistics, the probability of a collapse of the circulation, you really need to care about the past 300 to 500 years very carefully. And that actually really poses a problem. So from a digital twins development perspective, we can't incorporate that. And when you build a model, you care about the initial conditions, the boundary conditions, how you move the model forward, and how you assimilate data. So I think we need to be a bit more smart about how we take into account the history of the system so we actually get the right solution. So that's one point. A second point is that knowledge gaps. So this webinar is about commercialization, right? We all have a very impact-led perspective. And the reality is that for many of the problems that we will be interested in, fisheries, coastal protection, pollution, for many of these, really the bottlenecks of progress could be scientific knowledge, right? A lot of problems we deal with are urgent, but the urgency doesn't dictate how knowledge evolves. So we have this systematic problem in climate science that science has at times evolved much slower than actually needed. So how you actually deal with that is a separate thing, how you connect academic research with industry, how you create bridges between the basic research funds and sort of seed funds and translational funds to get to R&D and actually connect it. That's the whole other conversation, and those gaps are actually really hard to bridge, and people are working on it. But I think it would, I mean, I envision there will be cases frequently where a product is needed for a specific purpose, bringing in a certain amount of investment, but you can't get the solution that you want because the knowledge isn't there. And the process of finding funding or taking funding to a research institute and getting it approved and going through this cycle of bringing the funds in, advertising, getting researchers and so forth, that can be 2-3 years timescale, which is really long. So I think that as this spins up, we need to find ways that we can actually really quickly exchange information in terms of knowledge development and commercialization, and be able to make informed sort of cooperative decision that, okay, this is the best that we know, let's use that even if it's really terrible to make the product and then improve that knowledge over time. That workflow exists in medtech, it exists in engineering, but it doesn't exist in climate environmental science. And I think that actually there's a bit of culture change in that there should be a realization that we can't understand everything in time, then what do we do with that? And so that's one point. And the last point I'm going to come back to is data. Of course, we all talk about data. There are data sets that are global. We talked about remote sensing. Increasingly, there's commercial remote sensing. The sort of publicly available global international data sets, as important as they are, they're very difficult to get funded. They're difficult to sustain. At times, some of them go out of budget, and they don't get renewed. But increasingly, we're getting commercialization. We have a lot of private satellites and in terms of autonomous monitoring of the ocean, the deep ocean, in terms of deep ocean communication and acoustic technology, all of that is really evolving really rapidly. And one point I want to make is that still the way we create models is, let's say if you think about the digital twin of the ocean, regional or global, we think about, let's get the dynamics right. Let's add tracers. Those could be pollutants, they could be nutrients that link to chemistry and the carbon cycle. So there's a sequence that we evolved them, which is not too dissimilar to how climate models evolved, historically. Now, at the end of the day, if you really want to scale the solution up, it's going to be really resource limited, because these are going to be very expensive, and running them won't be really expensive necessarily. I mean, it won't be the bottleneck, but the bottleneck would be the amount of data produced and how you use it, how you make it accessible, how you make it understandable. And when you assimilate data in these models, you will need to make choices about which data you care about more, because you can't be as close in terms of your solution to all the data. You have to put weights on it. So which data you care about more? You want to be more close to the dynamics, or you want to get the carbon right, or you want to get the extreme waves right? So those decisions really come down where the investment comes from, what's the solution you want to get, what's the stakeholder engagement. So I think stakeholder engagement, even though we talk about it, in this particular case should happen really right at the beginning, at the design level. The one should be able to say that we want to be able to cater to these potential solutions and then have experts to explain, okay, these would be the informations that we want. And then from that, you can work out a priority list and try to optimize that. And that would be a very non-trivial practice. We're not on the nerdy side, people that actually create the models and assimilate the data and so forth are not used to thinking about it for historical reasons, for how we learn how to develop models in the climate community. But again, I think we need to really change the approach a little bit and put the application and the needs right at the very beginning. Otherwise, this won't be investable. And the last point I want to make is that I think digital twins, I mean, on the data point, sorry, last 2 points. On the data point, I mean, we are all obsessed with AI now, and it's really growing rapidly, and we have a lot more computational power. So we could actually very quickly get to the point that we have a lot of these twins. And just want to emphasize that no matter how much resources we throw at this, we can't fill in the data gaps and the knowledge gaps, and they go hand in hand. And so I can foresee a situation where we're going to have a lot of twins and a lot of solutions, and it would become difficult to identify what is real or not. We can easily get really overwhelmed, and we should think about that systematically, and that really requires sort of community coordination. So even if the information can't be shared depending on the investments, but at least there's a common language, there's a common way to know what is correct or what is not. Because as opposed to climate models that were created for a global good and shared publicly, if you want to spin up a business model, then these would be very isolated. And how can you actually keep the IP safe, but coordinate such that you know that we're talking about something that's reasonable and it's not complete nonsense. And the final point, I think digital, I mean, following up on what Phoebe was talking about, I think digital twins actually have a real opportunity to help us develop a framework for sustainable economy, even if it's theoretical. So you can actually take that and make the point that maybe you can actually design policy on it. I am involved with carbon removal industry in a consulting sort of capacity. So I talk to a lot of different companies, and a problem there, especially in the marine side, is that there are a lot of suppliers, there's no investment. And the reason there is that it's not actually clear what you're investing in. In an ideal world, you would want to be able, you would need a valuation of the gain in terms of, let's say, benefits to biodiversity, right, and ecosystems, or you can think about blue economy, natural capital. So those don't actually exist, but digital twins can actually help you create those in an interactive way where you have your interventions built in as socioeconomic models. So when you do something, you can actually see the benefits and the damages and evaluate that in economic terms, and then gauge that against inaction. And then you can come up with something that's actually investable or not. We are very far from that. And even if we get there, translating that into policy on global scale is just too optimistic. But at the very least, this can actually provide a framework for theoretical socioeconomic models that can give us some hope. So I think those are all the points that I wanted to make.
Yeah, thank you so much, Ali. A lot of food for thought.